think about 10 years into the future. How do you imagine it? Perhaps you believe that cars will be flying, or everyone is wearing alternate reality glasses that allow them to view the path to the nearest McDonald's along the sidewalk. Perhaps clothing trends look completely different, or there's a new brand of soda that is as popular as Coca-Cola. No matter what you envision, it is almost certain that some people will be in self-driven cars. Now, some people will say, "Oh, I'll never trust a self-driving car. It's far too dangerous and too risky for me." But we'll soon explain why that future is much closer than you might think. Now, there's a lot to handle, but we will begin with an overview of AI and machine learning, which will lead to a better understanding of computer vision when it is explained. After that, we dive into the technology of the self-driving cars, their history, potential pros and cons, its future effects on society, and lastly, how to best implement them into society.
Machine learning is a set of statistical techniques and computer algorithms that improve with experience or being exposed to environmental data. The more training data that is exposed to the AI, and the more tests that are run, the better the AI gets at fulfilling its tasks. Said training data can take place as a multitude of things, only limited by the amount of types of data that can be put into the model. Common examples of data are series of numbers, strings of text, series of strings of text, two-dimensional images as a series of pixels, and many other forms. Hopefully, when all the training data goes through the model, any future data, even data that hasn't been tested or seen before by the model, will produce a prediction that is highly accurate. One of the most common and understandable models is a neural network, which can be symbolized by several columns of circles, or nodes, that eventually reach a final circle, connected by a large amount of strings. As the data goes through the first layer, each node churns out a different number, which in turn affects the next layer of nodes. Eventually, the last node is the prediction. Based on how far the prediction is off from reality, each node will be tweaked so the numbers it produces are altered slightly, and hopefully closer to the correct number of the result in 100% accuracy. Neural networks work much better when used to complete specific tasks, much like how a worker that does a single job does it much better than one that does 10 different jobs. These specializations form various branches of machine learning that conquer different generalized problems. The specific branch of machine learning that we will be looking at is computer vision. Computer vision handles the issue of interpreting a two-dimensional image specifically to determine what is in it. For example, types of computer vision software handle problems like identifying people in surveillance cameras, locating text on a screen for automatic subtitling, and identifying pedestrians, road signs, and other symbols important for driving a car. How these work is that a neural network is set up, and pixels from the image are grouped and processed through the neural network. As the machine learns with each picture or frame, it should improve identification of common objects, such as people, animals, cars, or other objects that stand out from the environment. This software has been used for over a decade now, and has therefore seen a lot of use. The reason it hasn't been applied to self-driving cars yet is because the consequences of 1% of error could result in a car crash or collision with a pedestrian. The other reason is that images are very difficult to interpret. For example, how can you tell the difference between a reflection of a person through a puddle versus a normal person? Or how can a computer cope with warped and angled views of objects? Due to the immense complexity of visual data, writing a computer vision AI that has an incredibly high rate of success is quite a tall task.
Self-driving cars. Self-driving cars are, as the name implies, cars that drive themselves. They are able to control most aspects of driving on their own without a human's control. They are able to analyze their surroundings and acknowledge that they need to drive carefully to make sure that both passengers and pedestrians are safe. Now, obviously, self-driving cars need to be perfected before they can be taken out on actual streets. Countless hours of testing need to be conducted to make sure that every aspect of the car is close to perfect. Although this seems far away, technology is rapidly changing and self-driving cars seem to be more plausible each and every day.
While the history of self-driving vehicles begins before modern computing, we will only cover the autonomous vehicles that used computing to accomplish this feat. We first begin in the 1930s, a time before computers and in the midst of the Great Depression. People needed escapism from the drab reality of America and used comic books, science fiction, and many other means to cope. Out of this sparked the thought of something revolutionary. People going down a highway, but without having to drive. The crux of the issue, and why little to no progress was made for around 5 decades, was because the road is a complex environment, filled with road signs, obstacles, potential dangers to passengers and pedestrians, and dozens of other unforeseen issues. Around the 1980s, up towards the 2000s, computing finally caught up with humanity's dream and attempts were made. Notable accomplishments are Ernst Dickmans created a Mercedes van that drove for around 200 miles on a highway. Tsukaba Mechanical Engineering Lab used early computer vision to achieve 20 miles per hour on roads by tracking white street markers. And the Argos project had a 94% autonomous vehicle drive 1,200 miles around Italy. Up until the present, a lot of progress has been made in computer vision, AI, and self-driving cars in general, although the unforeseen variables have still kept them from overtaking the people-driven cars. The most notable contenders in this race to see who can make the first fully autonomous car is Google and Tesla. In 2012, Nevada allowed Google to use autonomous cars on the road for testing, and a few other states followed after. On the other hand, Tesla has already implemented an autonomous driving function in their vehicles, which can be interchangeable with normal driving at any time. Although there are other contenders, these two appear to be the closest competitors to achieving the fully first autonomous vehicle. In recent years, many different things have improved with self-driving cars. Major car manufacturers believe that self-driving cars will allow the following advancements to take place: real-time route adjustment and reduced energy consumption. Now, deep learning is the driving force behind self-driving cars. Improvements in deep learning technology will greatly increase the effectiveness of self-driving cars. Specifically, deep learning makes the prediction algorithm exponentially better at predicting unforeseen or new problems when compared to supervised learning. For example, if the algorithm has only seen pedestrians as pets and people, the odds that a deep learning algorithm will swerve out of the way of an alligator in Florida is significantly higher than with a supervised model, which has never seen an alligator. Other recent techniques include a rise in edge computing and 3D object detection. What the rise in innovation in 3D object detection is, also known as point cloud, does for self-driving cars is that it makes the distance from the car a new type of data, making decisions much easier to handle. Edge computing is the innovation of computing to the edge of the chain, which in this case means that computing would be added to the parts of the car, such as the tires, the steering wheel, and many other parts. This will make the computing much faster, and therefore decisions can be made in the blink of an eye. But the real question is how this affects society.
Society is positively affected due to a plethora of reasons. To start off, the crash rate will greatly decrease. There will be fewer crashes with the implementation of self-driving car technology. These self-driving cars will have faster and more consistent crash detection systems. Also, since the cars are self-driven, the cars are not prone to driver distraction. 6 out of 10 teen crashes involve driver distraction. Because self-driving cars are focused 100% on driving, they will be more cognizant of their surroundings. Also, people will be able to get more work done because they wouldn't have to waste time driving to work. People could also get more work done from the car, leading to an increase in productivity. Because of this increased productivity, families will be able to spend more time bonding together and less time at work. When cars greatly benefit society, it naturally follows that there are some downsides. One potential downside is that self-driving cars create downward market forces on auto manufacturers, causing their sales to decrease. Driving is an important skill, and there are tangible losses for a society in which the skill of driving has become something of the past. There will still be one-off events in which a person behind the wheel could have done better than an autonomous vehicle. There exist other economic losses too. Imagine the amount of labor it takes to excavate a pit mine or haul cargo cross-country or transport individuals through a city. All of these jobs are at serious risk of automation. 3 million people make up the American transport sector. The steady salaries provided by these jobs are not easy to replace. What will these people do after their jobs are gone? This is a question that society has left only the trucker to toil. Retraining a younger transport worker is a challenging task, but retraining a 50-year-old trucker is Herculean in its difficulty. It must be mentioned that this is not the fault of the trucker. Those who have been made economically unemployable must not be confused with the unemployed. Whilst there is still much to gain from a properly handled transition to a world with autonomous vehicles, mishandling this transition will lead to an economic catastrophe. Computer vision is a revolutionary technology that will greatly impact labor markets. Self-driving cars represent one and likely the most impactful application of computer vision. Autonomous vehicles are the most efficient way to transfer objects from location to location. They can be used to move boxes in factories, humans around the world, or goods from production site to store. The application of this technology will increase market efficiencies, leading to a reduction in the price of goods. Consequently, the quality of life for those who can acquire said goods will increase. However, it is important to analyze how and which markets are affected. Goods are becoming cheaper because a cost is being cut somewhere. Labor often accounts for a third of a company's expenses. The reduction in the cost of goods is a direct consequence of the reduction in the cost of labor. In this case, the partial replacement of labor with capital is that cause. Computer vision represents an existential economic threat to some workers, and this will cause social strife.
How to fix the issues of self-driving cars and the future of self-driving cars. Social strife rooted in deepening inequality is a challenge that the United States is familiar with. Of the OECD nations, the United States has one of the Gini coefficients, which is a measure of income inequality. However, this type of inequality is rather new. The cause of inequality throughout the United States history has been the denial of opportunities to certain groups of people. The type of inequality caused by self-driving cars is new because it removes any opportunities that could be provided to people. People put out of work from the applications of computer vision algorithms are not unemployed. They are unemployable. The best currently available solution is to institute a universal basic income or a negative income tax. A universal basic income would supply some amount of money to all, meaning those who are not adversely affected by self-driving cars would receive a check. The threshold to be taxed would be increased such that those who make little money would receive tax rebates from the government. Neither solutions are perfect, and maintaining current social programs is still very important, but both solutions seek to redistribute the gains of the applications of these technologies.
Autonomous transportation is a wonderfully disruptive technology. It has the capacity to greatly increase the efficiency of markets. However, in doing so, it will displace many jobs. With the utilization of adequate social programs, the benefits of self-driving cars can be harvested whilst mitigating the losses. Thank you for watching.